Hello, class. Today we'll be looking at atomic structure. So today we'll be looking at some of the particles you can find in an atom, their charges. We'll also be looking at the meaning of atomic number and mass number. But you will also recall that while we're treating nature of matter, we said matter is made of small particles known as atoms. So today we'll be considering what these atoms are. Okay, the most basic unit of any substance is the atom. You can think of our atom just like the solar system. This model was given by Bohr, okay, where the mass is concentrated at the center and the smaller objects orbit round the central mass. What is this central mass? The central mass is known as your nucleus, as you can see on the left screen. Okay, so where we have the green balls and the blue balls. This can be found in the center, which is known as the nucleus. And we have two major particles you can find in the nucleus, and they are protons and neutrons. Okay, and the reason why they are concentrated at the center is because they have a relative mass of 1. So they are heavy. So that is why they can be found at the center of the atom. The third subatomic particle that orbits round the nucleus is known as electrons. Okay, is known as electrons. And what are they? Why is it that they are found at the orbit? Why are they not at the center of the atom? The reason basically is because they are very, very, very light in weight. Okay, so since they are very light, they cannot, concentrate at the center of the nucleus, but can only orbit round the nucleus. This diagram here is a typical example of the structure of carbon. Okay, if you check your periodic table, carbon has atomic number of 6 and a mass number of 12. Okay, so 6 denoting we have 6 protons, we have 6 electrons, and we also have 6 neutrons. This we'll be looking at as we go ahead into the lesson. Each element contains atom with certain number of protons. The number of protons gives the identity of a particular element. What I mean by that statement is that when in most cases, we predict the atoms of a particular element or identify a particular element basically by the number of protons it contains. Okay, so when you discover a particular element and the number of protons there is 6, you already know that element is carbon. Okay, so that is how we identify elements. This can be likened to the DNA of everybody on Earth. Every human being has a unique DNA. And that is why when you touch anything and the DNA test or sample is taken, you can be tracked down and traced. It can be traced down to you, okay, because you are unique, because your code is a unique code as a human being. So the atomic number is the unique code of an element. It is the code, the number that we use to identify what element it is. Okay? So, and the atomic number can simply be defined. Atomic number is simply the number of protons in an atom. Okay, that is what atomic number is, the number of protons in an atom. So a good example is the carbon we have up here has atomic number of 6, hence it has 6 protons. Okay, it has 6 protons. Another thing of note that we need to take note of is identifying the atomic number when you see them. This is very important because in some periodic table, instead of you having the mass number as a superscript up here, you may have the atomic number as a superscript. So what will give you the insight about what the atomic number is basically look out for the smaller number, okay? The smaller number is always associated with the atomic number on your periodic table, regardless whether it's placed as the superscript up there or as the subscript down there, okay? But in most cases, it's always expressed as your subscript, the way I showed it here, okay? Another example is, let's look at lithium atom, 3, that is the atomic number, and then the mass number is up here, 7. Okay, so the atomic number is also equal to the number of electrons if we are considering an atom. Okay, in an atom, the number of proton is equal to the number of what? Neutron. I mean electron. Sorry for that. Atomic number is equal to the number of protons and also equal to the number of what? Electrons when we are looking at what? Atoms. Okay? So in an atom, that is what we have. We have proton equals to electrons. The reason is due to the fact that protons are positively charged, electrons are negatively charged. Atoms are neutral particles. They are neutral. So if they are neutral, that means they possess equal positive and negative charges. Okay, that is what makes a particle neutral. When you have more of the positive than the negative, then it's no longer neutral. That means that particle is positively charged. If you have more of the negative than the positive, that means the particle is negatively charged. But when you have equal amount of positive and the negative particles, then you can say you have a neutral particle. Okay, so atoms are neutral. So the number of protons already give you an insight on the number of electrons that you can find in an atom. And now remember, you will recall that what determines the number of protons is the atomic number. So when you have your atomic number, you already know your number of protons is equal to your atomic number, and then your number of electrons also equals to the number of protons if we are considering an atom. Okay, so another thing we have here is the mass number, okay, or the atomic mass. It is used interchangeably. So whenever you have the atomic weight or mass number, is basically the sum. Atomic mass is basically the what? The sum of the number of protons and neutrons in an atom. So That is, I see the atomic mass as what you can find in the nucleus of the atom, because those are the particles that determine the mass, the weight of the atom. So the protons and neutrons that are found in the nucleus determines the weight, because the mass of electron is infinitesimal, is almost negligible. Okay, so it's not considered when looking for the weight of an atom. So when we want to get the weight of an atom, we simply add the number of protons we have and the number of neutrons we have in the nucleus. Okay, that gives us the atomic mass or weight. Okay, now let's take an example, lithium now. We have our lithium atom, 7, 3, and lithium. Okay, we know the atomic number is 3. Look at the atomic number equals 3, and then the number of protons also becomes 3, because that's what determines your atomic number. Okay, and then the number of electrons. Since this is an atom, the number of electrons also will be equals to 3. Okay, to ensure neutrality. Okay, and then the number of neutrons, since your mass number is 7, the number of neutrons will be 7 minus 3 protons, okay, to give 4. Okay, I believe this is clear. What we did is basically, since the mass number is the sum of protons and neutrons, you already know the mass number to be 7. So if you are to solve it in an algebraic manner, you say atomic mass, okay, Am equals to my proton plus my neutron, okay? And then if I'm to show that, I will say my mass number is 7, which is equals to my proton, which is 3, and then plus my neutron, which I don't know. So if I make the neutron subject of the formula by collecting like terms, I move this 3 here to the other side. I get my N to be equals, that is my neutrons, because 7 minus 3. Okay, and that becomes 4. Okay, so that accounts for the number of neutrons in the atom. Okay, so another thing I want us to consider before the end of the class today is how do we show the number of protons, number of neutrons, the number of electrons in an ion, okay? In an ion, ions are charged particles, okay? Particles that have charge, okay? Take example, we have lithium here. Still using lithium as my example. And now I have a positive sign here. Okay. This positive sign means +1. Okay. If it were to be 2 or anything above 1, I will indicate the number. But since it's 1, I can just leave it as plus. Okay. So now for charged particles like this, you need to be very careful, because it means that I have, the charge of protons. Protons are positively charged. Electrons are the negative ones. Okay? Your neutron, on the other hand, has no charge. Okay? So when you want to tell the number of protons and electrons, in a charged particle like this, which is known as ion, okay, lithium ion, we just simply say the proton will remain the same. It's the electron that determines the charge. If you have excess electron, the ion will be negatively charged. If you have less electron, okay, insufficient electron, then the charge of the particle will be positive. But the proton remain constant. The proton will not change because that is the identity of the element. Okay, so my proton here, I will say P is still 3, but my electron is not. What is the charge of this ion? The charge of this ion is simply +1, which means I have more proton than electron, and the difference is 1. So that means my electron should be short of 1, okay? So my electron basically will be 3 minus 1, which is equals to 2, okay? The formula for this is atomic charge, as you can see on the left screen, atomic charge, you can see the atomic charge is equals to the number of protons minus the number of electrons, okay? So that should give you your charge. So if you're to use this formula, all you need to do is just say the atomic charge here is what? +1. I will say +1 here, okay? The number of protons in lithium is 3, okay? I am looking for the number of electrons. I'll just make that E, okay? Because it's the electron you always want to look out for. The proton is exactly what you have as your atomic number. So when you do the math, you discover that you're going to have electron to become 3 minus 1, which eventually will give you 2 electrons. Okay, so that is how to solve problems like this. Okay, so that's how to solve problems like this. So we move on to taking 1 or 2 exercises because of our time. Our time is fast spent today. So if you have any question, you can ask me anytime, any day. Okay. When we meet again, we will look at other aspects of this topic. But before we go, I want you to try out 2 questions on your own and see whether you'll be able to tell the number of protons, neutrons, electrons in some of these particles. So you can try this out. A particle with 35 protons, 36 electrons, and 45 neutrons, and then the other, and then the third one. Okay, just give it a trial. Okay, and whatsoever you have, you can bring it to the next class. At this point, I would like to say bye. So we'll meet again.